Welcome to our channel, where we dive into the mesmerizing world of microscopy. Join us on a captivating journey as we unlock the hidden beauty of the micro and nanoscale universe. In this series, we'll explore the fascinating realm of microscopic imaging, from the elegant dance of fluorescent molecules to the intricate landscapes of cells and materials. We'll delve into the different types of microscopy techniques, each revealing a unique perspective of the invisible world. From the gentle illumination of light microscopes to the astounding detail of electron microscopy, we'll uncover the secrets of how these instruments work and what they can reveal. Get ready to witness breakthroughs and innovations that have earned brilliant minds Nobel Prizes and changed the way we see and understand the world around us. So, don't miss out on this extraordinary voyage into the realm of microscopy. Subscribe to our channel, hit the notification bell, and let's embark on an incredible journey of discovery. Introduction to microscopy. Microscopy is a powerful scientific technique that allows us to observe and analyze objects and structures at a scale that is otherwise invisible to the naked eye. It has played a pivotal role in advancing various scientific disciplines, from biology and medicine to material science and nanotechnology. By using specialized instruments, microscopy enables researchers to explore and understand the intricate details of the micro and nanoscale world. Types of microscopy. There are several types of microscopy, each tailored to different imaging needs and resolution capabilities. Light microscopy uses visible light to observe samples. Includes bright field, phase contrast, differential interference contrast, DIC, and fluorescence microscopy. Electron microscopy uses focused beams of electrons to achieve higher resolution than light microscopy. Includes transmission electron microscopy, TEM, and scanning electron microscopy, SEM. Confocal microscopy uses laser light to create optical sections of samples, providing 3D images and reducing out-of-focus blur. Super-resolution microscopy techniques like STED, SMLM, and PALM break the diffraction limit, enabling imaging of structures at the nanoscale. Atomic force microscopy, AFM, uses a sharp probe to scan a sample surface, providing high-resolution 3D images of surfaces and biomolecules. Working procedure. Microscopy involves several key steps. Sample preparation. Samples must be appropriately fixed, stained, or treated to enhance contrast and preserve their natural state. Microscope setup. The microscope is adjusted and calibrated based on the imaging technique used and the desired magnification and resolution. Illumination. Light sources or electron beams illuminate the sample, interacting with its components and generating signals or images. Image formation. Light or electrons interact with the sample, producing an image that is then captured by detectors or sensors. Image processing and analysis. Captured images are processed, enhanced, and analyzed using software to extract valuable information. Sample requirements. Sample preparation is crucial for successful microscopy. Fixation preserves sample structure by chemically immobilizing cells or tissues. Staining enhances contrast by adding dyes that bind to specific components, making them visible. Sectioning for electron microscopy, samples may need to be thinly sliced using specialized tools. Mounting samples must be appropriately mounted on slides or holders for observation. Applications of microscopy. Microscopy finds applications in various scientific fields. Biology and medicine, studying cells, tissues, and microorganisms, aiding in disease diagnosis, drug development, and understanding biological processes. Materials science, characterizing material structures, defects, and properties for materials design and quality control. Nanotechnology, visualizing and manipulating nanoparticles for advanced materials and devices. Forensics, analyzing trace evidence and identifying materials in criminal investigations. Geology, examining rock and mineral structures to understand Earth's history. Precautions. Sample contamination, prevent contamination to ensure accurate results. Radiation exposure, use proper safety measures when working with electron microscopes. Sample damage, avoid high-energy beams that can damage delicate samples. Proper training, operate microscopes with proper training to prevent damage and ensure accurate results. Eye protection, protect your eyes from intense light sources. Microscopy is a versatile and indispensable tool that continues to advance our understanding of the world around us. By choosing the right microscopy technique, preparing samples carefully, and following precautions, researchers can unlock hidden details and gain new insights into various scientific phenomena. Thank you for joining us on this immersive exploration of microscopy. If you enjoyed this video and want to stay connected, be sure to like, share, and subscribe. And remember, there's always more to discover in the world of science and microscopy. Until next time, keep exploring, keep learning, and keep your curiosity alive. See you soon.